Consider this function. Let capital F be the antiderivative. With capital F of 1 is 0, find capital F. Okay. So let's first rewrite little f of x, this function right here. It's going to be 2x to the minus 2 minus 4x to the minus 5, right? Down there, because, powers on the bottom, that's negative powers, right? So that's just the rewrite. I haven't done derivative, antiderivative, haven't done anything. That's just a way of rewriting where the x's are up in the top. Now I want to do the antiderivative, capital F. What's the antiderivative? Remember now, so the anti, so you know the derivative rule. If you have x to the n, the derivative is in x to the n minus 1, right? Well, the anti is the opposite. The antiderivative, you add 1 to the power. Instead of multiplying by that, you multiply by 1 over that, or no, it's dividing, same thing. So that's what we're going to do. So we're going to come in here, we're going to add 1 to the power, so that'll make it x to the minus 1, and then that 2 in the front will divide by that. Next comes the minus 4, and we're going to add 1 to that power. So that'll be x to the minus 4, and then divide by minus 4. Okay. And remember, plus a constant. Whenever you do the antiderivative, there could be any constant number that doesn't have an x, like a 7, an 8, a 12, a 13, out here. Why? Because the derivative of any constant number would go back to nothing. So it's right. It's the antiderivative. Notice the antiderivative is anything whose derivative would go back. Like if I took, yeah, let's leave it at that. So it could be any constant number. So what would this be then? Simplifying. So capital F is, this is negative 2, right? 2 over negative 1 is negative 2. X to the minus 1 plus 1, right? Two negatives make positive. X to the minus 4 plus, again, any constant number could be there. Okay. So now what is that constant number? Well, they specifically tell us that capital F of 1 is 0. So if you plug in 1, what do you get? Minus 2 times 1 to the minus 1 plus 1 times 1 to the minus 4 plus any constant, and that equals 0. Why? Because they said so. They said when you put in 1, you get 0. When you put in 1, it equals 0. Okay, well, what am I going to do with this now? Now I can solve for that constant. This means minus 2 over 1 to the positive 1. Remember, negative powers jump to the bottom. And so that's just minus 2. This is 1 over 1 to the positive. Again, negative powers jump to the bottom. So that's just 1. Plus the constant is 0. Now that means minus 2 plus 1, minus 1, plus the constant is 0. Okay, now solve for the constant. Add 1 to both sides. Boom, boom. The constant is positive 1. The constant is 1. So that means our anti, this right here, is 1. So the final answer for the anti, bring it down here, capital F, the anti, is equal to minus 2x to the minus 1 plus 1x to the minus 4 plus the constant, which is 1. There it is. There's the antiderivative. It's the antiderivative, and that's the same exact answer they got up there. And how could you check it? If you took the derivative of it, it would go back. You know what I mean? Here, let's just go to the answer. If I was to take, here's how you can check an antiderivative. Take the derivative of this, what would happen? The minus 1 would come down, right? Minus 1 times minus 2 is plus 2. Subtract 1 from the power, x to the minus 2. Perfect. And then here, the minus 4 would come down, minus 4. Subtract 1 from the power, x to the minus 5. What's the derivative of the 1? Just 0. It just go away. See how it's right? The derivative of this goes back to our original function. So this indeed is the antiderivative. And so again, what we did, we did the antiderivative rules, and then we had to find the C, and we plugged in what they gave us. F of 1 equals 0, solved for the constant. The constant was 1. So there we go.